Good evening. I'm Elaine Provenzano. I'm a librarian here at the Tuckahoe Library, and I'm very excited to introduce Harmeet Goindi, who is a CFA. Um, uh, he's an engineer by education, a teacher at heart, and a FinTech entrepreneur by choice. Tonight, he is going to be talking about what is ChatGPT. And if you read the paper every day, there is something in there about it. So he's going to give an insightful talk on AI and ChatGPT and explore the latest advancements and real-world applications of artificial intelligence and discover how ChatGPT, a cutting-edge conversational AI, simulates human-like conversation. Harmeet?
Thank you, Elaine, for that kind introduction. So yes, as Ellen mentioned, the news is rife with the talks of AI and ChatGPT, and if you remember a few months ago about Stable Diffusion, the DALI, the art project. So basically, and everyone is interested, and we are going to today talk about AI. And the question of this talk is, has the age of AI finally come? Because as I talk about it, you will realize this is not the first time that we are getting excited about AI. This has been going on since 1950s. So let's go and talk about AI and what it all means. So what is AI, right? At the essence, it's just intelligence that machines demonstrate. Some of the examples that we see every day of AI are pattern recognition. So you can pull up your Google photo or Apple iPhoto app and type wedding, and it'll give you pictures of wedding. It knows about weddings. So not only will you get you pictures of weddings where the bride is wearing white, as in the West, but red as it is in Eastern culture. So it recognizes it. Same with birthdays. It knows birthdays for, birthdays from various cultures, and it'll just bring the picture out for you. And so, this is everyday use of AI when you talk to your Siri or Alexa, you just say, hey, Siri, tell me about the weather. It knows what you're saying. It knows what you want, and it just gives you the weather. And then there is this self-driving car. Tesla has it, Waymo has it. I mean, that's, I guess, a pinnacle of AI technology. It, not only does it know where to go, but it also knows how to avoid accidents and people, and how to stay in the speed limit, and how to follow signs. And then, of course, there are these creative generative tools that we are going to talk about today, like ChatGPT. And then games, right? From I think 50s or 60s, we have made games that beat human in checkers. And in 97, if you remember, Deep Blue beat Gary Kasparov. And more recently, Go, Google made a machine that defeated humans in Go. So all these are example of AI. But what is also AI and that we don't talk about is common stuff like GPS, Google Maps, face recognition and fingerprinting recognition when you are unlocking your phone with your face, or when you use your fingerprint to unlock a door. That's also AI. Automation like Roomba, the vacuum. I mean, I had it like 11 years ago. I'll clean my apartment. It'll know when not to go down the stairs. It knew everything. It would map it out, and you put the Roomba into a new room, it'll just map it out and do it again. So that's 15 years ago. Agriculture has been using AI for, again, decade, more than a decade. I think it's a multi-billion-dollar industry. Tractors and weed whackers and all those things. And then more recently in McDonald's and Domino's, they have waiters that are robots, and they come and take your order. And then when you play Spotify or Netflix, it gives you next suggestion based on what you have seen or you like. That again is example of AI. But for some reason, we don't think this as AI. We think as we just take it for granted. And there is a name for it. It's called AI effect, right? Things like, as I said, GPS and Roomba is not considered AI. In fact, one of the earlier use of AI was the mail sorter. When you write a zip code in your letter and you post it, there is a sorter that post office has that sorts mail. And this was, I remember 20 years ago, people were working on it, right? I mean, this has been used for more than 2 decades now. So the AI effect is basically when onlookers, right, and us, we discount the behavior of AI program by arguing it's not real intelligence, right? When it becomes a part of daily life, we don't consider it AI. So a theorem by scientist Tesla, right? He says that AI is whatever that has not been done yet. So give it time, and ChatGPT will not be considered a part of AI. It'll just become like how you use Siri or Alexa. But let's to understand AI, right? We have to go back in the past to look at the history. Artificial intelligence, right, has been with us from time immemorial. I think it's something about humans wanting to be God and create an intelligent being. And so this is a quest that's nothing new. It's since ancient Greek, in fact, even before that. So, I mean, if you look, every civilization has an automata, and craftsmen build it. I mean, if you go back to Chinese civilization, the Greek, the Egyptian civilization, they all had an automata and craftsmen who would build it, machines that could do certain things. The oldest known was the sacred statues of ancient Egypt and Greece. And then you see up top here, it's a picture of a man. It's basically Talos. And I don't know if you have seen the movie Jason and Argonauts, where they fight this giant and I think defeat him. And then on the bottom here is a picture of Golem, right? It was, I think, in 13th century. It was the first known, first documented case of making a golem. Golem is basically an automata you make out of clay. I think in Middle Ages, it was believed that, you could take a clay and insert a piece of paper with God's name, and then it'll come to life. And, people believe that, all these figures, craftsmen had basically imbued these figures with real minds and capable of wisdom. And I think that was just our hubris trying to see we can do what God did, I suppose. And recently, in 19th century, the Frankenstein novel, right? Again, you make a monster out of thin air. So we have been dealing with AI for a long time, but the real history of AI begins about in 1600. So the foundation of AI has been laid, by the giants, and we are just walking on it. To begin with, right, in 1600s, Blaise Pascal was a very famous inventor. And in fact, he's so famous that there is a computer language named after him. And he first invented a mechanical calculator, the first, I suppose, computer of some sorts. And at the same time, in the same century, Leibniz, he was a polymath. He was an inventor, a philosopher, a mathematician. He, by the way, invented calculus along with Newton. And he basically believed that human reasoning could be reduced to calculation of sorts, right? And he invented a language for it, and which basically, led to AI that came later on this century. So we'll get to it later. But again, one of the other contributions that he did that is very important is he invented binary system, which is what computers use right now. And then in 1700s, Bayes was a scientist. He came up with Bayes' theorem and the rise of Bayesian statistics, which is basically all the statistics that we know right now, foundation of information theory, foundation of computer science, right? So they led the framework for it. Now, one of the things that you see in the picture in top right, it's a Wolfgang's chess playing automaton. It was called the Turk. So it was in 1700s, he invented this machine and it could play chess, and he went on world tours and he defeated almost everyone, including Napoleon Bonaparte and Benjamin Franklin. He went on for 84 years. And it turned out that this was not an automated machine. It was actually a very smart chess player who was hiding in the machine and playing pushing the levers so that it looked like it was being done by an automated machine. So it was an example of the first hoaxer of 17th century, I suppose, 18th century. But again, you can't discount his impact and effect. It basically gave rise to fascination with something, machines that can solve real problems and play real games. And then in 1800, Charles Babbage and Linda Lovelace, Linda Lovelace was, by the way, the daughter of poet Byron, the legitimate daughter of poet Byron. they made analytical machine, which you see in the picture in the museum in the bottom left. So this was basically the first computer, multi-purpose, not multi-purpose, mostly for calculation, but a computer. Now they tried to make it and they couldn't because they didn't have the machine, the tools, the parts, the material they needed to be machined to a very fine detail, and they couldn't do it. So he couldn't complete the machine, I think, in his lifetime, but it was done later on, and that's what you see in the picture. And again, George Boole invented Boolean algebra, but very useful, needed for all the things that we need to do in computer science. But that was, early, and then the real work begins in 20th century, right? That's when things really pick off, I think, both in mathematics, logic, computer science, and in physics. It was basically the early part of the century was a golden era, if you like math and science. That's me, I suppose. So in 1913, right, formal logic got basically shot in arm when Bertrand Russell published Principia Mathematica. So logic, we know logic, I suppose. You have watched Star Trek, we know Spock talks about logic, but that's informal logic, right? Formal logic is what they took this logic and made it into a science of basically deductively valid inferences of logical truths, right? It's a formal science. It's not subjective, and it investigates how conclusions follow from premise in a topic neutral way. So that was formal logic, and that was very important for computer science and AI. And in 1923, it was the first time the word robot was used in a play. And 1931, I think, is one of the most important years for mathematics and philosophy and logic. So this was the year when Kurt Gödel came up with this incompleteness theorem. Now, I don't know whether many of you are aware, but this was a seminal work in philosophy. And the implication of this theorem came as a shock to everyone, including mathematical community. So he was to math what I suppose Einstein was to physicists. And but what he said implies that there are true statements that you can never prove to be true, right? And so you can never know for certainty if they are true now, or they could turn out to be false later on. Basically, which also implies that the whole mathematics might be inconsistent, and we will not know for sure whether the math that we are doing is consistent or not, and we might find out later on, in decades later, that all we have been doing was basically invalid. So it's a very, very seminal work, and in fact, he was so important and celebrated that when he came to, so he escaped Nazi Germany and came to Princeton to study in IAS, the Institute of Advanced Studies, with Einstein. And Einstein said that when Einstein was getting older, he said, my own work no longer means much. I come to Institute merely to have privilege of walking home with Gödel. So, and then he did work with Einstein to improve his some of the conclusions that he got from theory of relativity. Anyways, there are some, John Newman talked a lot about Gödel's. There are a lot of things you can read up about Gödel, and I think we should probably have a lecture just on him. But moving on, right? In 1937, Alan Turing came up with the halting problem, something similar to what Gödel did. Basically, it says that, you cannot, from looking at a computer program and input, you cannot tell whether this program would stop or not. So basically, both this theorem basically prove that, or to paraphrase J.R. Lucas, that minds cannot be explained as machines, right? I mean, that's what they're trying to say in some sense, and that AI, a machine can never do what humans can do. Like mathematically, it's impossible. I'm paraphrasing it, and there are some problems with what I'm saying. That's the gist of what the work they had done. And then Turing also made Turing machine, right? The concept of Turing machine. So Turing machine is basically the foundation of the computers that you see today. So he made a machine, and all the modern computers you see are based on Turing machine. Turing also came with Turing test. So the Turing test is that to know whether a machine is really capable, sentient, so to speak, is if you're speaking to it and you do not know whether it's a person or a machine, then you know that the machine is sentient. So basically there's like when we talk to ChatGPT, we do not know whether the person who's responding is a machine or a person, right? When you see it, you would probably be fooled that it's a person. And that is, saying that ChatGPT has passed the Turing test. In 1950s, Isaac Asimov came with 3 laws of robotics, which is basically a foundation of how to make a robot that will not destroy humanity. And again, in 1950, Claude Shannon came up with his thesis, The Mouse. So this, and he came up with this machine, right? It's a labyrinth. It's a labyrinth which is 25 squares, and he made an artificial mouse, and mouse could find a way out of a labyrinth. But the way it would work is it would remember the path it took. And then you can change the labyrinth and mouse could still find a way out. So it was the first example of AI, right? That worked. Now, Claude Shannon, for those of you who don't know, is the father of digital revolution. He founded what is known as information theory. So all the encryption, the computer science, anything that has to do with digital stuff, your phones, is basically based on his theory. So again, he's whole tech revolution, Silicon Valley owes almost everything to this guy. So that's the 1950s is basically where the current modern AI starts. And in 1956, there was a conference in Dartmouth College. It was called the Summer AI Conference, and it was hosted by Claude Shannon and John McCarthy and Marvin Minsky. Again, they're all known for, well known in this artificial intelligence community for doing a lot of work in that field. And it was then that McCarthy coined the term artificial intelligence. And so 1956 is when the term came. And there was a lot of, after this conference, there was a lot of excitement and investment in this field. Department of Defense and DARPA spent a lot of money into it. And there were 2 schools of thought into solving the AI issue. One was symbolic AI. If you remember, I talked about it when I was speaking about Leibniz, the guy who invented calculus. But basically, symbolic AI is reducing the world to symbols and teach the AI these symbols so it can learn the world, right? So more formal way of teaching. And the connection approaches model the AI after human brain, right? So how the neurons are, so the concept of perceptron, and then make AI based on that. The symbolic AI approach was much more pure in some sense, right? It was the way purists thought of doing it. And so people started working on that, and it worked for a while. I think the first checker machine used that, but then things didn't work out. You didn't get results that you wanted. And we had what is known as first AI winters of the 70s. Research died down. There was no money. And then there was a brief revival when Japanese came into it. And so US thought we should also invest. We don't want Japan to win the war. So there was a brief revival, but then it died again. So that was the second AI winter. And then in 1990s, it was revived, but not by the symbolic AI approach, but by connectionist approach, where you use neurons to model the AI rather than a symbolic way of doing it. And that is what has continued so far, right? So there was a brief, again, winter, but it came back again. So if you see in 2010s is when the excitement really began. You had the Watson, remember, from IBM beat everyone in Jeopardy in 2011. And then in 2012, right, like deep learning came and things became much, much better with Google Photos and voice recognition. So what I'm saying is that we have gone through this cycle where there's excitement in AI and then it dies down. It comes back, it dies down. So this right now, what we are seeing is third or fourth cycle, depending on who you ask. And there's a big possibility that all the excitement we are seeing will just go away and it'll just become a part of our life, just how GPS has become a part of our life. So just to recap, 50s and 60s, in 50s, artificial intelligence, people were excited about it. Then things died down, and then machine learning came, which is the approach of neural networks. And then 2010, deep learning. And we'll talk about these terms as we go along. Came and it's stuck, and that's what ChatGPT is based off. And I guess that's more consistent with Gödel's incompleteness theorem. Again, a different way of looking at it is there's this big field of artificial intelligence where we want to imitate intelligent human behavior. A subset of it is machine learning. And as further subset of that is deep learning, though for my purposes, I will use machine learning, deep learning, and neural networks interchangeably because they are very, very, very similar. So all of it is that like Russian doll, right, nested inside. So before we go into how ChatGPT works, I just want to take like a minute to tell you how our brain works, right? So because it's modeled after brain. So the picture you see is that of a neuron, right? And neuron has a nucleus, right, in the middle, the big thing, the big blue thing, and it has dendrites, those branches coming out from this big blue thing, and basically a long stem, which is called the axon, right? So the branches in the top, in the left side, that surround this big nucleus are called dendrites. The center is called soma, and then the big branch that is going towards on the right side is called axon. So this is how a neuron look like, right? And these dendrites are connected to other neurons via axon, or to sensory input like touch or smell or eyesight. And so they get information from either other neurons or from other sensory inputs, and they can have about 100,000 inputs, right? So they get input, and then mathematics happen inside soma, and then all it does is the end result is it sends a spike on axon to the axon terminal, or it doesn't. That's all it does. And this axon terminal are connected to, again, other neurons, right? And so basically it's a big network of neurons connected to each other, and each deciding whether to fire or not. And that is how we make decisions, based on whether a neuron is fired or not, right? So a simple example is, when you grow up and when you're born, you do not know cat from dog, right? So your neurons, right, they get this image of cat, and then you don't know what it is, right? You'll think it's mama or daddy, and then you'll be corrected, and then your neurons will rewire themselves and change the way they are processing, and to say, okay, this is a cat. So this keeps on happening 500-600 times, and then you know what cat is, you know what dog is, right? You're learning from trial and error, and all that's happening is your neurons are getting rewired when to fire a spike on axon and when not to fire. They just change that, and with time you train your brain to recognize a dog from cat. Like, if you look at the picture, the dog is very similar to cat. It has 4 legs and 2 eyes, and as cute, if not cuter than cats, nose, but you know the difference. Now, if an alien came here, it'll not know the difference. It'll have to be taught. And that is the feedback loop that your brain has. And that's how brain learns. In fact, if you look at our brain, right, people believe there is this just one algorithm that brain uses, right? It's called the one learning hypothesis. Maybe there are a few more algorithms, but maybe there's just one. And the way that people came up with this is what they did with animals is the auditory cortex is where you have your ears are connected to your brain. So your brain basically listens and decides. What they did in animals is they cut the nerve from ear to the auditory cortex, and they rewired the nerve from the eye to the auditory cortex. So basically, with time, right, the part of the brain that was trained to hear could now see. And they did that with the part of the brain, the somatosensory cortex, the part that's used for sensing. They cut that and connected eyes to it, and the eyes nerve to it, and it could learn to see. So the point is, brain can learn with enough feedback, trial and error, feedback loop. It can learn to do other functions. And so this was a very important finding for the scientists, and this is what led this whole idea that neurons can be rewired and reprogrammed, led to the invention of neural networks, right? Which is what deep learning or ChatGPT is based off of. So basically, that's what we did. Humans copied the neurons, right? And that's how it looks like on the top that you see. It's or maybe you can look at the bottom. And this is how a neuron looks like, and this is what a neural network looks like. Again, it has inputs. Input could be, as I said, 100,000, 200,000 input. Right now, I just showed 3. And then there is this calculation that happens in the middle, and then there's output, right? So just like a neuron signals that they get can be from like outside source, like an image or other neurons. And then, there's a decision center in the center, which decides whether to fire 1 or 0. And then there's an output, which decides whether it's a cat or a dog, for example, right? So this is all you need to know about neural network. It is just like how a society and your mom and dad taught you how to tell a dog from a cat. Neural network, you do the same thing, right? You have to train it. And it's the way I give you a simple example of how training happens, and then that should sort of give you an idea of how things work. So let's look at a neural network to train to decide whether it's a cat or dog, right? So what do? You take an image, right? And this is an example of image, and you convert it into a binary form, right? So on top, it's a picture of Abraham Lincoln, and it's converted into this grid with numbers. And if you really want to think about it, you can just think of it as zeros and ones, zero where there is white and one where it is black, or 0 and 1000, 0 where there is white, 1000 where there is black, 500 where there is gray, 250 where it is less gray, and so on and so forth, right? So you make an image, and it's just image is like a two-dimensional thing, right? So you have a two-dimensional matrix, and you convert it into a one-dimensional matrix. So basically what I mean, so this is an image. You basically cut, just like how you cut a photo into strips, you cut this image into strips and you join them together, right? It's called flattening. So now it's just a big strip of just ones and zeros, numbers, right? And you just feed it to a neural network. You just connect it, you have these neurons, and each neuron is connected to all of these image pixels. Basically, pixels is what you're talking about. And then there are weights inside it, right? And then you put an image, and then it'll output cat or a dog. If it's a cat, you tell it, yes, you're right. And whatever weights it has, it'll increase them. If it tells it's a cat, in this case, it was Abraham Lincoln, you will say no, and it will then decrease its weight. And you keep this process going 100,000, 200,000 times, and you have taught a neural network how to identify cat and dog, right? There's no magic here, right? These weights inside, there's a little bit of magic, but how the weights change, that the magical part. But idea is the same. You just keep on feeding the pictures, and the weights are readjusted by the program automatically. I mean, you can do it manually too, but that is not the right way. Automatic is faster, and so you just have you train the model to find cat and dog. Now, when you've done this model can only do cats and dogs. If you give it, if you say, hey, is this a peacock? It'll have no idea. In fact, there was this story. I don't know how true it is, but so neural networks have been in existence from like 60s and 50s, right? It's nothing new. So back then in Vietnam War, they were training. They had satellite images of tanks, and they were training a neural network to identify tanks so that they could use these bombs to just destroy it, and people don't have to go. And it worked very well, right? The training. And when they tried to use it in real life, it failed miserably. And then they found out that what they were using, the pictures of tanks, it had a lot of tree covers. And when they were using pictures of no tanks, there were no tree covers. So what they actually trained the model to do is identify forest or tree covers versus no tree cover, and not tanks versus no tanks. So you have to be careful as to what you are training. But that's what it is. That's the in a sense a neural network, very similar to how we learn. So just to give a brief summary of it, you have input, you have some weights assigned to it, and you just change the weights depending on when you get the results. Initially, you assign it randomly and keep on telling it pictures of cats and dogs and peacocks and whatever. And then you tell it, no, you're right. Yes, you're wrong. Yes, you're right. No, you're wrong. And it keeps on readjusting. And the reason, as I say, it was done in 50s, this technology. But the reason it's picked on more prominence now is because we have lots of images we can use to train. So it turns out there is this inflection point. So when you train it with like millions of pictures, right, then it starts getting much better. Much better, which they did. And also the computing power. They didn't have computing power back in like 50s, 60s, 70s. Now they have the computing power. So technology is not new, but the hardware and the compute power is. Right? So where do we use neural network for, right? The facial recognition. So for example, when you have your iPhone and when you get it, it asks you to look at the phone, so phone can take pictures of you from different angles. That's what it's doing. It's training its neural network about your face. Same with fingerprints. It asks you to take fingerprint 8 or 7 times. That's what it's doing. It's training neural network about your fingerprint. Same when you do OK Google or Siri, it asks you to say stuff, and it's doing the same thing with voice. Shazam for music does the same thing. It listens to what's being played and uses neural network to identify the pitch, so instead of pixels, here it has other variables like the amplitude, the intensity, the pitch, and so on and so forth. Netflix recommendation, they use the same thing. Just brief difference between simple neural networks that was in 1950s that I was talking about and deep neural network, right? So these are much more complex. They resemble our brain much better than what we had in early part of the century. So this deep neural networks became popular and possible in 2010 onward, and this is the one that revolutionized the field, right? Now I use the word interchangeably because no one really uses simple neural network. They all use deep learning neural network, but that's what everyone uses, right? It's just many layers. It's more similar to your brain. Okay, so that's the basic of it. Now let's just go and talk about what we really came here to learn about, which is the ChatGPT. ChatGPT is again type of deep learning model. It's called large language model. It's based on the same thing I talked to you, neural networks, right? Same concept. It's also what is known as generative AI, right? Because it's used to generate stuff, not classify stuff, right? And now we talked about images, right? How we use pixels. Instead of images, it uses words or tokens. Tokens are phrases. And for it to work, it needs a lot of training, a lot of training. And again, there is no magic here, right? It's just training and data. And let me give you an insight as to how it's made, so that when you see it next time, you won't be that impressed. So going back to Claude Shannon, right? The father of revolution, the OG, right? The guy who invented a lot of things among, but the mouse that could find its way out of labyrinth. But what he did, right? He was the first one to, I think, invent ChatGPT. What it did is he started with the seed word, right? So in ChatGPT, you start with a phrase. He started with a word called the. Then he went to a library, opened a book, picked a book at random, opened the page at random, and try to find the first occurrence of the, and then try to find what came after the. So what he got was the head, right? So then he says the head came. So then he has this phrase called the head. Then he chose the word head, and then he opened another book and tried to find the first occurrence of the word head. And then whenever he found it, he chose the head and whatever came after it. So it was an. Then he chose an, and he went and kept on doing it till he got this sentence. And the sentence is, the head and in frontal attack on an English writer, that the character of this point is there for another method. Doesn't make sense. It sounds right, right? This is what ChatGPT is all about, basically. But it's a little bit better than this, right? So let me give you another example. There's this author from New Yorker who I think last week, it's called Cal. His name is Cal, right? He did something similar what Shannon did, but instead of with one word, he used 4 words. So he picked the book from Mary Shelley's Frankenstein, and he first picked any 4 words at random. And then I continued walking in, right? 4 words. And then what he did is he took the 3 words, continued walking in, and he tried to look for it in the book, and he found it. And then he looked at what the next word was. It was this. Then he stuck with walking in this. And then he looked in the book to see if he can find an occurrence of those 3 words and what was the next word after this. And that was manner. And so he kept on going to picking 3 words, and then finding the 4th one. And then he came up with this sentence, which says, I continued walking in this manner for some time, and I feared the effect of the demon's disappointment. This is a very nice sentence. It makes sense. And it is made by, again, a human ChatGPT in some sense, right? Now, what ChatGPT is just this, but multiplied by like 1 trillion times, right? So what for ChatGPT, you do the same thing. You take all the text in the world, right, that exist, all the chats, or everything that has happened, and you then look at all the phrases and you assign probability. So instead of us looking at trying to find these 3 letters, like continued walking in this case, trying to find the fourth letter in this one particular book, the world is an oyster, right? So you just find what the next word could be, and ChatGPT will give you probabilities of next. So for example, when you say the grass is, right, ChatGPT will give you a bunch of possibilities. Grass is green, grass is wet, right? It will also give you grass is not good for health, but there's very low probability it's going to come up with that, right? So most probably it'll give you green and wet. And so it comes up with probability score, and randomly you pick, or the ChatGPT picks the next word, and then you have the grass is green, and now it has that particular 3 letters, and then it tries to find the next word based on the probability, right? So that is all ChatGPT is doing. And the way it comes with these probabilities is, again, neural network that I taught you. It's trained, it just finds the next one, right? And so there is no magic here. It's just probabilities and neural network. And you can, if you are sophisticated enough, you can write your own ChatGPT. So where is ChatGPT used, right? I'll give you a demo after, maybe I can do this now. Give me a second. So ChatGPT can be used for writing songs, poems, lyrics, writing resumes. Here, so I'll bring up this ChatGPT, and let's say write a song about the whole library. And can you see it? Can you see this, guys, or it's too? Let me increase the font size. So it wrote a song about the whole library. Wow. Nice. And now say write it in rap form. So it's going to write in rap form, and let's say song about and it'll just right, and you say, okay, and you don't like the style, you say in the style of Tupac, right? So now it's going to write a song inside of Tupac. And so the way it's working is, remember I told you it has probabilities. Now when you give Tupac, it goes through Tupac's all the song that he has written, and then the probabilities are higher. Oh my God. Tupac's thing, right? And not to think. And you can say in the style of King James Bible. And look, let me just stop. But look, Temple of the Mind. And low in a wondrous place to be, right? So now what's doing is giving higher probabilities to the Bible and Bible kind texts, kind of text. That's what it's doing. So it's all about same neural network. It's trained. It's not just giving more weights to something that sounds biblical, right? Now let's say I work at SIPO, right? So let's say write so I'm a product developer, resume for the product manager role with 10 years of experience in CBOE, right? That's my company. You don't know, you probably have not heard of my company, but this guy knows everything. Look, it wrote a resume. Product manager, 50 million revenue. It knows, it's great, right? You just write everything, and it knows it'll even make your degree for you, so on and so forth. So it knows, it's very, very smart. So basically it has taken, if you are a creative writer, well, there goes your job, right? I mean, it'll just write anything. Then coding, it can code, right? So I can say, write a code. You have a program code in Python to sort integers. I mean, this is an easy program, and it wrote a code for you. You can just copy paste this code and it'll just work. So, simple coding job gone. It is very good for debugging. So if you write a code and you don't know how to work it, it'll find faults on it, right? Sales pitch, right? So write a sales pitch for hand soap. I don't know. Look, new line of hand soap, keep your hand clean and fresh and moisturizer, right? So when you're writing something, it can be very useful for giving you tips and insights. And so, you don't have to go to internet and look for, hey, what should I write? Ask ChatGPT, and this is where you can start. Basically anything, right? I mean, if you have time later on, we can play with it, but anything you want, it'll just do for you. But know that there is no magic here. All it's doing is it has all the information in trained, and it's just giving probabilities to, when you type it, it looks at it and just gives probability to what should be the next word. That's all it's doing. But it works. And the reason it works is because there's so much training that has gone into it. There is, as I said, there's an inflection point. So it will not work with like 1 billion books, or but it'll work with like 1 trillion books if it knows. So that's something about this large language models that now people don't know how it works. Just so everyone is clear, no one knows how a neural network deep learning works. Like, what are those weights? How does it work? Just like we don't know how a brain works. We just know it works, and so we know it works, but not how. Right. So coming back to, this is generative for words, but there is generative AI for pictures. So there is a project called DALL-E and Stable Diffusion, where you can say, I want an image that does this. So let me give an example. So I just said I want a New York City impressionist painting. It gave you, let's say we want to see fox eating apple. I guess it doesn't like that. Bad eating. So while it generates that, I'll just show you another creator. Yeah, so let's, now it can do drawing, photos. Let's say New York City in Mars. Let's see if it can do it. So these are, again, it's going to take time. When it's done, I'll show you, but it takes about a minute because it's a free version. ChatGPT have the paid version. For these guys, I don't. So the point is, like, this one is a fox impressionist picture of a fox, right? There is there goes, artists, and when you have to pay for stock images, you don't have to. You can just generate it through AI. And then there's this, again, by Google, there's a thing called Image, and I think it's free. So you can take your picture and put it in, and you can say, hey, change my picture to look more like this or more like that, and it'll just look, and you can't tell the difference. Here. So this is the result, fox eating an apple. Just made a picture. So this one is good, this one is not so good. And look, New York City in Mars. That's what it's going to look like. Right? And so there goes artists and creative people's livelihood. So this is based on what is known as stable diffusion, right? Again, this happened like last year or 2 years ago. And look at this. These are pictures of people who do not exist. They were just made by AI. There is a website that says this person does not exist.com. You can go there and you can keep generating images of people that don't exist, right? And now this is where you get into this dangerous territory, right? I mean, there's a use for it, I suppose, for modeling, right? You don't need for clothes, for underwear, for example, you don't need to use real people. You can just use artificial people. But that also means that models have lost their livelihood in some sense, right? So it can be very, very dangerous. So AI is nice, but it has problems. And let me show you a problem. And this video is 5 years ago.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things. at least not in a public address, but someone else would. Someone like Jordan Peele.
So this basically, and you can see it online, this was Jordan Peele just made a AI, and this was 5 years ago. Right now it's much more advanced. So what does it mean? It means that anything you see on the internet, any video, any images, you just can't trust it. It's so perfect. There's no way you can tell a difference. And so yeah, it's a fake news, propaganda, all that stuff becomes much more easier with AI. So it's something to keep in mind. So next time when you read article or see news or watch a video or photos, just keep in mind everything could be just a fake made by AI. So for ChatGPT and AI, I say, right, with great power comes great responsibility, and use it wisely, which we are not doing currently. There are a lot of issues with AI, as you have seen. There is a lot of biases that people talk about in AI. It's like in US, for example, as I said, it has to be trained, right? So if you're training, if you are, you only know a certain culture or certain things, and you're a programmer, so you'll only train that data set with what you know. And so certain things will be missed out. So there's a lot of bias there too. So AI is something that we have to be very, very careful about. But let's not talk about that. Let's just talk about ChatGPT. So any thing here that you would want to ChatGPT to answer your questions, or want me to give you a demo of something on ChatGPT, please type it in your chat and we can have some fun with it, because we have 10 more minutes.
So we have a question.
So regulation, okay. There are no regulation or control from a federal or state level. There are industry regulations. So I don't think I can say something bad here. Wait, how to make a gun? Yeah, see, so if I say how to make a gun, it'll not tell you how to do that. So these guys have the companies that make AI products have put in some controls in place. But the technology, as I've just shown you, is not that hard. Like, you can write it yourself. So, and if you have a powerful enough computer, you can just do whatever you want to do with it. So no, there is no control in place. But companies have been so far nice about it. They have blocked it. But it's a matter of time when it's from out of the hands of the company and goes to individual, and then it's game over. Yeah, oh, I'll tell you one. So I just went on vacation, right? So if you're going to a vacation, right? So let's say you're going to Iceland. So you can say for 7 days vacation. It'll tell you what to do. So if you're going for somewhere, you can just use it to plan itinerary. So basically, whatever you can think of, it has an answer for that. Now, some of them might not be great answers, but it will give you an answer. So there's a question about copyright, right? So so I think that is not yet resolved. But yeah, there was a book that this guy wrote, children's book, and put it in Amazon using the images that I showed you. He pulled it out because copyright issues are not solved. The question is, how do you prove that it has violated your copyright, right? Because this is whole of internet. So to prove that, yes, this particular image, the one that I showed you here, right? Give me a second. Violates someone copyright, it's going to be very, very hard to prove.
Harmeet, I had a question along the same lines. I know that some that I work with on the history committee was using ChatGPT, but there were no citations. So if you're looking for a historical record, and you may find some great information, but it's not backed up, how can you use that?
No, so as I said, I won't use anything that comes out of ChatGPT.
Yeah.
Right, but it's a tool that can help you, right? So if you say, hey, tell me history of what happened in battle or whatever, it gives you something. You don't trust it, but you use it. Like this itinerary that came out Iceland, this is great. I'll use it and I'll go to internet, try to confirm it. Similarly, right, the score, right, a lot of times it gives code that has bugs, right? Or this resume is basically useless. It's nice, but it's useless. So it's a nice starting point, but it's not Google or it's not Wikipedia. You can't trust it. And again, as I said, it's trained. And there was a time when it would give you wrong results, especially when it came to Nazi propaganda and stuff. And then they pulled the plug on that particular piece. But because, whatever is in the internet is what it is being trained on. So if it is trained on, and let's say that in case of Nazi, I'm just using an example, most of the stuff is negative. So it's going to just say those negative things, right? Or in a positive light. So you have to be very careful when you use ChatGPT. I think use of it as a friend. Hey, what do you think of this? And he'll tell you something and then go with it, but don't use it as the authority. Yeah. Yeah, so there's a question about informational issue. Yeah, you can't trust it, right? So for information, ChatGPT have to be used very, very carefully. If it is something that is very simple that you can find in Google, then ChatGPT is fine. If it's something more in-depth, I wouldn't trust ChatGPT. Like I didn't use ChatGPT to make this presentation. Although, let's see, 40-minute presentation on ChatGPT. Now it tells you what to do. But again, it's, as you said, it's fluff. There is nothing much here. Students have, so MCATs and USMLEs, you can now pass on this. I'm using, which version is this? Give me a second. I am using 3.5. I think I can, if you change it to the latest version 4, this is, this is like the Uber version. This you can pass MCAT and USMLE with it. So this is much more advanced than what I just showed you. But again, it is good for some things. It's not good for certain things. Just like how Google is good for certain things and not good for certain things. So it's a tool, and it'll become a part of our life, and we will learn to live with it and use it very well, like how we use Alexa or Siri. But soon it'll not be called AI. It'll just be called Alexa or ChatGPT. How to climb Everest. Anyways, sorry. Yeah, any other question? I think we have 4 more minutes, or we can play with it.
So if you want, when it says regenerate response, it will redo it at the bottom when it says that.
Let's say, okay. So yeah, so it tells you, right? It's when I say how to do it in winter, then it'll tell you how to. It's acting as if it understood what I said and it's telling me what to do. So it's much more responsive. It's almost like talking to a human being who knows a lot.
That's interesting. Wow.
So do we have means to detect? I mean, there are some means, but with ChatGPT 4, it gets harder and harder, right? Even with videos and pictures, it's not easy. Like what happens is, first of all, the quality of video and stuff is, if it comes in YouTube, it's not good enough, right? So all the artifacts of AI generation goes away. There are still ways to detect it, like how, because it's just building based on other pictures, so the shadows might not fall there and so on. But it's an increasingly difficult task.
Any more questions? Well, I want to thank Harmeet for sharing this with us. Very, as Anne-Marie is saying, very helpful, a lot to think about. And I'm sure there'll be more to learn in the future. And I think the one thing I learned is how old this technology, how long this has been around, and just been added to. So very, very informative, enlightening.
I
And
just
there-
want, I
There's a
want to say,
song about
Huh?
the core library.
I know, that's what I was going to say, Harmeet. I love this. You showed us how to do the Tuckahoe Library song. Can you send us a copy
I'll
and paste and send it to
I'll
us?
sing it at the baby time next week.
Yes, send it to us, Harmeet. That was great.
National
I will.
Library Week, we'll do it.
Okay. Okay. I will send it.
Wow.
Thank you
Thank you
so
so
much.
much, Harmeet, and thank you, Elaine, and thank you everyone for joining.